Welcome back to Project Guts on chemical reactions. Now we are ready to run some experiments. In other words, we're ready to run some simulations. One thing we can change is the mixing of the reactants. So you see that the copper strip is stationary, however the silver nitrate is moving around in solution. And so how can we measure the rate of reaction and change the mixing or the movement of the silver nitrate and see if it has any impact on the rate of reaction? Well, first of all, you have to run the experiment under the same conditions over and over again. So the same amount of copper and the same amount of silver nitrate. And when you're studying the rate of reaction, you really want to watch the time. And you want to watch the time when half the copper atoms have been used up. The copper atoms in this case are the limiting agent. And so when half of the limiting agent is used up, check the time. The larger the time, that means the slower the reaction. The shorter the time it takes for half of the reactants to be used up, the faster is the rate of the reaction. So in this case, I'm just running it all the way till the copper is used up, just to be sure that it is copper in this case that is the limiting agent. And notice how the graph starts really steep and eventually will level off. So that's why we need to look at the time when half of the amount is used up. So or half of the products is produced. So we're expecting to have 300 silver atoms produced. So right there at 150 is where you want to look at the time it's taking for 150 silver atoms to form, or about half of 150 copper atoms used up. So and here we are, and this reaction just ended. So I'm going to click the forever to stop the model from running. So this is kind of what we're expecting. So now run this over and over again, of course, and get an idea of how much time it took for 150. So if I look this way and I look down, it looks like about 100 ticks or 100 time units in this module. So let's go down to the code, and since the silver nitrate is the only reactant that is moving, copper is not moving, here's the wiggle movement for the silver nitrate, and let's change the angle. It's kind of like the swirling angle or the stirring angle, the mixing angle. So from 25, I'm going to change that to 90. And let's see the effect of this type of movement on the rate of reaction. Again, we have to click Run Code. Since we changed something in the code, Setup, add copper strip, add 500 silver nitrate, same amounts, and click Forever. And let's watch the graph. So we're waiting for all the copper atoms to be used up. If we're quick enough, we can actually click and stop the model right when half of the copper atoms are used up, but we can also let it go all the way and then look at the graph. In order to not make this reaction go faster, but in order to make the model go faster, you can increase the speed right here of the model execution, just so things happen a lot faster. And now that we changed the random angle of the wiggle walk to random 90, it seems to have a lot more movement, and we want to see the effect of that on the rate of the reaction. Of course, you don't want to rely on one trial. You got to do it again and again and again under the same conditions to see if there is an effect on the rate of reaction or not. And we're almost done. And I can already see from the graph that at 150 silver atoms produced, the time is about 200. So it slowed down the reaction. Now, is this a conclusive conclusion? Well, we have to go back and redo this again and again. But here is the graph. I'm going to stop it. And right at 150, half of the silver atoms produced, you see it's about 200. Okay, so I'll leave that for you to try with different angles.